Okay, let's check out graphing some linear relations and tying that to equations of linear relations. So it's come up a little bit in the course so far, but let's look at this linear relation. So here we have a table of values, 0, -3, 1, 1, 2, 5, 3, 9, 4, and 13. And then I've graphed them. There's the x-axis and the y-axis, and I plotted all the points, and it made a straight line. So let's point out some key features that we've learned so far. So we've learned that linear relations have a constant rate of change. So they're going up by the same amount each time. So I can tell right from the table that this linear relation is increasing by 4 every single time. I can see that. The x values are increasing by 1 every time. So I can see that my rate of change, or my slope, is equal to 4. I can also tell that from the graph by picking 2 points and seeing that those points have a rise of 4 and a run of 1. So I can tell that my slope is 4. There's also another really important feature of a linear relation, and that feature is called the Y-intercept, or the initial value. That's come up before too. And the Y-intercept is the value where x is the y value where x is 0. So this guy right here. So when x is 0, y is -3. So that's what our y-intercept is. We can also tell, so this is the y-axis right here that I'm highlighting. That's the y-axis. We can also see right from the y-axis that the line crosses the y-axis right at -3. And that's the value when x is 0. So that's an important feature of our graph. So it turns out if we know just those 2 pieces of information, we can make an equation of any linear relation. And one way to do that is using this form of an equation called slope-intercept form. And it's written like y equals ax plus b. Or you may have seen it as, instead of an a, sometimes it's an m, whichever form. So let's write that. So if we had to write the equation of our relation, we would put the slope in for a and the y-intercept for b. So the equation of this relation would be y equals 4x minus 3. That would be the equation of our linear relation. And that's kind of like, that's how our x values are related to our y values. So like, for example, let's say if I had the x value of 4. To turn it into a 13, I would have to multiply this 4 by 4, giving me 16, and then I would have to minus 3, which gives me 13. Okay, let's take this value of 3. If I multiply it by 4, I would get 12, and then I subtract 3, I would get 9. So you can see that that equation does describe our linear relation. So y equals 4x minus 3 would be the equation of this relation. And we found it easily by just knowing the slope and the y-intercept of a linear relation. And then sometimes we're given the equation of a linear relation and we may have to graph it. So let's say we knew that y was equal to 2x plus 1. So right away from that equation, I can see that the slope or the rate of change of this linear relation is 2, and I can see it has a y-intercept of 1. So if I wanted to, I could make a table of values given this equation, and that's often handy to do. So x's are my inputs. So I can put anything I want for x. So I could put -1 or 0 or 1 or 2 or 3. And those are all the things I will input into my equation, and then it will give me my output of y. Okay, so let's say I input a -1 into the x position. So let me show you what that looks like. So I would have 2 times -1 plus 1. So that would give me 2 times -1 is -2 plus 1 is -1. Put that in my equation. Let's try another one. So let's try and input a 0. So 2 times 0 plus 1. So y would equal 1. Let's try another one. let's try an input of 1. So 2 times 1 plus 1. So y would equal 3. And another one. Let's put an input of 2. So 2 times 2 plus 1. So y would equal 5. And last one. Input of 3. Y equals 2 times 3 plus 1. So y would equal 6 plus 1, so 7. So that's how you could take an equation and create a table of values. And then from that table of values, you could graph a relation. So that's kind of going the other way. If you're given the equation, you can make a table. And again, we can see from our table, it's going up by 2 every single time. So that's our slope. We can also see that the y-intercept is 1, because when x equals 0, y equals 1. Okay, cool. Okay, last thing I want to show you. I want to show you how you could graph a relation given an equation. So let's say we had y equals, I'm going to make it a negative slope this time. Negative 4x plus 3. So I'm going to make myself a grid. Here we go, set of axes. So I've got my x and my y-axis. Okay, so the first thing I want to do is I want to plot my y-intercept. So I know that's my y-intercept. So I'm going to plot it on the y-axis. So when, 1, 2, 3. 3 is my y-intercept. So put that on there. And now I'm going to use my slope or my rate of change to get me the next point. So this guy tells me how much my graph is increasing or decreasing. It's also kind of helpful if this guy's a fraction. So I'm going to put it over 1 so that it's a fraction. So anytime you have a whole number, you can pop it like the whole number over 1. So that way it's a fraction. So now I know from my slope that my slope is equal to my rise over my run. So if I start at my y-intercept, I know that my next point is going to be down 4, 1, 2, 3, 4, and then over 1. And my linear relation is going to keep going in that same pattern. So down 4, over 1. Down 4, over 1. I could even go up 4, but then I have to go to the left 1. Because I know since I have a negative slope, my slope is going to go sloping down to the right. And then I could connect those points to the line if I want to. I always like to put arrows on the end of my line too, because that graph, that relation keeps going in both directions forever and ever. So that's how you could graph from an equation.